Hi guys. Today we're going to start talking about some special cases for solving equations. Okay, so I'm on page 43 in your yellow Unit 3 workbook. Okay, so I have a couple of equations here, and I see that it's asking me to solve them, which means I'm trying to figure out what x is. So I'm going to use my 3 legal moves to go ahead and find that value. So I'm going to keep my equal sign lined up. I see over here on the left that I need to do some flipping. So I'm going to rewrite that as 3x minus 2 minus x equals, and then there's no flipping over here. So I'm just going to keep that the same. All right, now on the left, I see I have some combined like terms or zero pairs to do. So I see I have a 3x and a minus x, which means I have 2x minus 2 is equal to, and again, I'm not changing anything over here yet, so that's still the same. Okay, so my next move here is to do some matching sets, and I see that I have two positive x's on both sides. Okay, so if I take away these two x's on both sides, they cancel out, and I'm just left with negative 2 is equal to 5. Now, is that a true statement? Hopefully y'all said no, because negative 2 is not equal to 5. So we ended up getting an untrue statement. Okay, and I want you to think for a second about what that means. Okay, is there any value for x that we could put in here that would make this true? Okay, because all of the x's ended up canceling out, that means that there is no possible way to make this equation true. So there is no possible solution. So if you get something like this, you need to write no solution so that that shows me you actually understand what it's telling you when you get an untrue statement like that. Okay, so that means there is no solution. Okay, excuse me. Moving on to the next one. I'm going to keep my equal sign lined up. On the left over here, I see I have some flipping to do. So 2x plus 3 minus 7 plus 2x equals negative 4 plus 4x. I'm going to do some combined like terms. So I see a 2x plus 2x, which means I have 4x. And then plus 3 minus 7 gives me negative 4. All right, now I have negative 4 plus 4x over here. And now I need to do my matching sets. But if you notice, something weird's going to happen here too. Okay, so if I cancel out this negative 4 on both sides for my matching sets, I can also can also cancel out this positive 4x. So then I end up having 0 equals 0. And is there ever a case where that is not true? Hopefully you're saying no, right? No matter what, 0 is equal to 0. Okay, so in this case, this is telling us that there is literally any number that we could put in for x, and because they end up all going away, any number will make this true. So this means that there is literally infinite solutions. We can put any number in there, and we would end up with a true statement. Okay, so this one has an infinite number of solutions. Okay, notice how it is different from that first one, because up here we got an untrue statement, something that is not possible. Down here, we got something that is never not true. Okay, so notice how we have the two opposite extremes here. Always, always, always true, and never true. Okay, to help us kind of visualize that, we can look down here at these two equation mats over here. If I were to do my matching sets, I would take away an x from both sides and two ones from both sides. So then I would end up having 2 equals 0. And like we said before, there is no possible number that would ever make this true. 2 is never going to equal 0. That is never going to be the same value. Okay, so this one is one that has no solutions. All right, and then if we look over at this other one right here, I could do matching sets with this one too, and I would take away an x and 2 1s from both sides, so I end up having 0 equals 0. So even if x were 3, I would have 3 plus 2, which is 5. Over here, I would also have 3 plus 2, which is 5. Okay, maybe it's 0. If I make x 0, I have 0 plus 2, which is 2. And then over here, I also have 0 plus 2, which is 2. Okay, so no matter what value I put in there for x, it will always, always, always be true. So that's why this one has infinite solutions. Okay? Okay, cool. Good talk.